Hey everyone, today we are going to continue to add and subtract rational expressions. However, we're going to talk about complex fractions. If you guys kind of like look at these examples, they look a little complicated. So complicated, complex. Anyways, complex fractions, we're going to treat them like a division problem, okay? We're going to focus on the numerator first and then go to the denominator. So we want to think of them as separate, all right? We still are going to need to include restrictions, but we want to include our x values from the original expression and the simplified expression. Okay, so that's just kind of a little reminder up there. So here's some steps to simplify complex fractions. First, if needed, you're going to rewrite the numerator and denominator so that each are a single fraction. Okay, we've already practiced the factoring, but you might want to rewrite that numerator and denominator so then you get one single fraction, kind of like what we have here. This would not be a single fraction because there's a minus sign there. Then you're going to divide the numerator and the denominator and factor them, and then you're going to simplify just like you would, or just like we have been doing so far. Okay, so this is already in, the numerator and denominator are already in a single fraction, and they are down here too. So we're just going to go ahead and factor these expressions out. Okay, so over here, this numerator, you're going to write num for numerator. That would become, let's see here, 4 and 1. So negative 4 plus 1, right? All over, this would be x plus 2, x minus 2. Okay. And then we are going to divide that. I'm going to rewrite this kind of like how we did the division problems in the last section. Whoops. I'm not going to do that actually. And we're dividing this expression by this guy, this fraction down here. So I have a GCF of 2x, it looks like, for the numerator there. And then I'm left with x plus 1. Yep. And then all over x plus 2. So it looks like my this problem looks like just what we did yesterday, right? So let's go ahead and start to list our restrictions. So x cannot equal negative 2 because that makes the denominator equal to 0. And it also cannot equal 2. And looking at this denominator, it cannot be negative 2, but we already have that listed, so we can keep going here. So now that I have this all factored out, this is going to be equal to, I'm going to rewrite this first fraction. And I'm going to multiply by the reciprocal, because whenever you're dividing by a fraction, you're really multiplying by its reciprocal. Okay? Alrighty. So then now we can just divide out our common factors. So let's see here. I've got an x plus 2, an x plus 1, and that looks like it. So then I'm left with x minus 4 in the numerator and 2x times x minus 2 in the denominator. Now if you want to distribute that 2x, you can right here, but it's not necessary. You guys just can leave it in factored form. I did forget to state though. So looking at our simplified expression, right, we need to look at any restrictions here. So x can't be 2, which we already have listed, but x can also not be a 0 from this guy, right? 2 times 0 is 0. And then also x cannot be negative 1, okay? So you have to look at your original problem, so the division, and then when we multiply by its reciprocal, you have this denominator of 2x times x plus 1. So make sure you guys are making note of that over there, okay? So that's where the 0 comes from and the negative 1. So both of these things are needed in order to answer that fully. Okay? Alrighty, let's keep going. Number 2. Alright, so first we need to write these in a single fraction. Notice that this is not in a single fraction, so let's go ahead and focus on the numerator over here. Now I'm going to do this. Sorry, guys. So I've got Let's see, I want to write this as a single fraction. This, I am going to make this a plus and distribute that negative sign just so I don't forget. The least common denominator of this fraction, I would need a x minus 1 over here. And whatever you do to the bottom, you got to do to the top to make it the same, right? So really we're multiplying by 1 here. Okay, and over here I need the x plus 1. Alright, so I'm going to go ahead and distribute that, and that will be my whole denominator there. So this will be x squared minus x plus, plus negative 1x minus 1 all over x plus 1, x minus 1. That's the denominator there. Alright, so now let's focus on the denominator of this guy. So let's see. The least common denominator will be x, this is a plus 1. So I'm going to do x plus 1 here, x plus 1 here, and then now those fractions have common denominators, right? So I get 1 plus 2x plus 2 all over x plus 1, because that's the denominator for both. Okay? Alright, let's go ahead and simplify these both. Combine our like terms. So I get x squared minus 2x minus 1 over x plus 1, x minus 1. Is that factor? Let's see. Factors of 1, the add or subtract to get 2. I can't make them both negative because that's a minus sign. So yeah, that's not factorable. This becomes 2x plus 3 over x plus 1. Alrighty, so now that I've rewritten those as single fraction, now I'm going to divide these two things. So I really have x squared minus 2x minus 1 over x plus 1 times x minus 1, and that's being divided by the denominator, which was 2x plus 3 over x plus 1. So let's go ahead and start to list what x cannot equal. It cannot equal negative 1 or 1 or negative 1, but I already have that taken care of. So I like to rewrite it like that just to be able to point that out. But now when I go to simplify this, remember, rewrite the first fraction, and you're really just multiplying by the reciprocal when you divide by a fraction. So looking at this form now, I gotta check for restrictions. Negative 1 and 1, those are both listed. If I plug in, let's see here, a negative 3 over 2, that will make that 0. If you're unsure about that, remember you can say 2x plus 3. I don't want it to equal 0. So now let's go ahead and solve for x. So 2x cannot equal negative 3. So x cannot equal negative 3 over 2, which I think is what I wrote. Yep, okay. Yep, I did my math right. So that's a way to like check yourself if you need to. Okay? Alright, so those are all my restrictions, and then let's go ahead and simplify this. So I got plus 1 plus x plus 1 there, and it looks like that's it, because this isn't factorable. So then this is, I don't know why I wrote it like that, x squared minus 2x minus 1 all over x minus 1 times 2x plus 3. And that would be your answer. Okay? Alrighty, last problem. Alrighty, looks like we have a complex fraction that needs to be simplified. And we need to write this as a single fraction and this as a single fraction. So let's go ahead and do that. Let's focus on the numerator first. So this is over 1, so this needs an x minus 4. Whatever you do to the bottom, you got to do to the top, because x minus 4 divided by x minus 4 is just 1. So you're keeping all the values the same, so that's good. So this becomes 3x minus 12, right? And then I have minus 2, because I can combine that all over x minus 4, because now that's my new denominator there. Which that equals 3x minus 14 over x minus 4. And I cannot factor out with 3, or there's no GCF really. Yep. Okay, the denominator now. Let's see here. Sorry, this line is bothering me that I accidentally drew. Okay. I'm missing an x minus 4 here. Oops, that's over 1, so I need an x minus 4 to show that the denominator is x minus 4. So that gives me 5x minus 20, because you got to distribute that 5. And then I have plus 4 all over x minus 4. And that simplifies to 5x minus 16 over x minus 4. And there is no GCF there either. Okay, so this problem is really 3x minus 14 divided by x minus 4. And that's all being divided by 5x minus 16 over x minus 4. So x cannot equal 4 from both of those, right? Okay, so this is really saying, hey, let's do 3x minus 14 over x minus 4 times the reciprocal of this guy. And let's check to see if I have any other restrictions. It looks like I'm going to have 16 over 5 as a restriction. And again, if you can't see that, remember this can't equal 0, so let's solve for x. So 5x cannot equal 16, so x cannot equal 16 over 5 when you divide both sides by 5. So those are my restrictions. When I simplify, the x minus 4s are gone. They divide each other out. So 3x minus 14 over 5x minus 16. And remember, you can't simplify that 14 and the 16 because they're being subtracted. They're not being multiplied, so you can't divide them, okay? And that is it. All right. Thanks for watching. Let us know if you have any questions. See ya.